Hey guys, so today I actually forgot to do an example 2 for the quicksort yesterday, so I'm going to go ahead and just do another quicksort example, except this time I will be doing it with duplicate numbers, just like I've done for all the other examples. So what I'm going to do is I'm going to go ahead and just remove this quicksort. So again, I'm going to need this space. And then again, for our initial item that we're going to check, we're going to go ahead and check the first item that we haven't checked so far, or the smallest index, I should say. So in this case, the smallest index is here, this 6, because in an array of numbers, this would be index 0, index 1, index 2, 3, 4, and 5. So therefore, the smallest index is going to be this 0. This will be our first pivot. So let me go ahead and get rid of this. And I'm just going to use an arrow to represent where my pivot is. Okay. So now what I'm going to do is I'm going to check all the items up until I hit either the end of the array or an item that is locked in place. In this case, there are no items locked in place, so we're just going to go until we hit the end of the array. And I'm going to check if each number is less than or greater than this 6. If it is less than, I'm going to swap with any possible greater thans. And again, I'll show you what I mean as I go through this example. So for instance, is 7 less than, or I'm sorry, what I'm going to be doing is I'm going to say less than or greater than or equal to, okay? And that's the way I'm going to go through this. So is 7 less than, greater than, or equal to 6? Well, it's greater than or equal to. Is 5 less than or greater than or equal to 6? Well, it's less than. And whenever we hit a less than, we have to check if there's any greater than or equal to's that we can swap with. In this case, there's this 7. So I'm going to go ahead and swap the 5 and the 7. So the 5 comes here, 7 comes here. 5 is less than, and 7 is greater than or equal to. Now we're going to look at the 8. Is the 8 less than 6? It's not. It's greater than or equal to. Is 5 less than 6? Well, it's actually less than. And because we hit a less than, we have to check if there's any greater thans or equal to that we can swap with. Since this is the first greater than or equal to that we have, we're going to go ahead and swap with this 7. So the 5 comes here, and the 7 comes here. And of course 5 is less than, 7 is greater than or equal to. And now, is 9 less than 6? No, it is greater than or equal to. Now what we do is we count how many less thans we have. We have 1, 2. So we are going to swap the pivot two spaces over. So we're going to swap it 1 and 2. So the pivot is now going to come to this spot here. And of course, when we did last time, I'm going to pretty much do the same thing where it looks kind of odd and we're building a tree. So the 6 is going to come over here. So I know that the 5 is going to swap places here. And then the 6 is going to go into this index. But instead of writing it in place, I'm going to go ahead and write it way up here. Okay? And the reason I'm doing this, again, this line is just showing that 6 is locked in place. It is locked in this index. And the reason I do that is because once you lock a pivot in place, you now have to check all the items to the left of the pivot and then all the items to the right of the pivot. So now what we do is we go over here and we have to check all the items to the left. So in this case, we're just looking at this left side right now. And just like when we first started, we're going to check the smallest index of numbers that we haven't checked. Well, this is index 0, and this is index 1, so therefore, this 5 is our new pivot. Okay? And now what we're going to do is we're going to compare 5 with all the numbers until we hit the end of the array or a locked in place number. And we're going to count how many other elements are less than 5. Now, is 5 less than or greater or less than, greater than or equal to 5. Well, it's greater than or equal to. So now we count how many less thans we have hit. And we hit 0. Therefore, we are going to swap it over 0 spaces. There's nothing to swap. So it's in the correct index. But when we do a swap, we have to go ahead and redo pretty much what we did with the 6. And that is, we're going to just go ahead, bring it up. We're going to use this line to demonstrate that it is locked in place. And then, because this was our new pivot, we have to check all the items to the left of 5 and then all the items to the right of 5. Let me go ahead and just delete these. Okay. So now we have to check all the items to the left of this pivot. And as you can see, there are no items here, which means we're done checking the left side. Now we have to check all the unchecked items on the right of this 5 pivot. And in this case, it's just this 5 right here. So what I'm going to do is I'm going to use this as our new pivot. Okay? And for this 5, we keep going until we hit a locked in place number and we check how many items are less than. Well, there are no items here, right? Because the next item over is this 6, which is already locked in place. So therefore, we've hit 0 items. So we swap it over 0 spaces. And whenever we do that, whenever we swap it over, this becomes our new pivot and it also becomes locked in place. So now what we have to do is we have to check all the unchecked items to the left of this 5 and then all the items to the right of this 5. Well, as you'll notice that there is no unchecked items that is less than this 5 over here and to the right of this 5 over here, which means we're done checking the left side of this 5. And then same thing with this side over here on the right side. We have already checked all the unchecked. There are no unchecked items between this on the right side of this 5, but also on the left side of this 6. So therefore, we are done checking the right side of this 5. And now there's no items that are unchecked between this 5 and this 6. So we're going to go ahead and stop looking at the right side of this 5. And that means we are done checking the left side of the 6. So now we have to focus on the right side of the 6. And when we look at the items here, we have to look at the lowest index of items we haven't checked. Well, if this is index 0, this is index 1, this is 2, 3, 4, and 5, the lowest possible index of items we haven't checked yet would be this 8 right here, since 3 is less than 4 and 5. So now what we're going to do is we're going to compare all the items until we either hit another locked in place number or the end of the array. In this case, there are no items that are locked in place to the right of it, so we're just going to keep going until we hit this end of the array over here. So now we're going to check with the 8 being our newest pivot, and we're going to check, is 7 less than or greater than or equal to 8? Well, it is less than. And is 9 less than 8? It is not. So we mark it as greater than or equal to. And now what we're going to do is we're going to count how many items were less than 8. Well, there was one item, which means we're going to swap the 8 over one space. And when we do that, again, whenever we swap with the pivot, the 7 is going to come over here. But this time, the 8, which is our pivot, is going to swap places. And again, we're going to go ahead and write it up here just to show that this is now locked in place. Okay? And then we're going to go ahead and check all the items left of the pivot and then all the items right of the pivot. So now all the items that are left of the pivot that are unchecked is this 7 right here. So 7 now becomes our new pivot. I actually should just redraw this line to show that this is our newest pivot. And again, we are going to compare 7 to all the items until we hit a locked in place number. In this case, it's this 8. And as you'll notice, there are no items that are for us to compare to. Therefore, there are 0 less than numbers. Therefore, we are going to swap it over 0 spaces, which means 7 is just going to stay right in the index where it's at, except now it is now locked in place. And whenever we swap a pivot, we have to check all the items to the left of it and then all the items to the right of it. So are there any items that are unchecked that are on the left of 7 up until we hit a locked in place number like this 6? Well, there are no items, which means we're done checking the left side. And then same thing for the right side. There are no items which are less than this 8, but also greater than this 7 that are unchecked, which means we are done checking the right side of this. And that also means that we are done checking the left side of this 8. So now that's all that's left for us to check, is the right side of this 8. So what we're going to do is we're going to check the smallest possible index of items we haven't checked yet. Well, in this case, it's just this 9. And again, we're going to keep going until we hit the end of the array. And we're going to compare with all the remaining items that are less than or greater than or equal to 9. In this case, there are no items, which means we are going to swap it over 0 places, which means it's just going to be locked in place right in the index where it's at, except this time I'm going to go ahead and represent it with this line. And then we have to check all the items to the left of 9 and then all the items to the right of 9. Well, again, we hit to the point where we have checked all the items that are less than 9 and greater than this 8. So there are no unchecked items, which means we are done with the left side of 9. And now we have to check all the items to the right side of 9, and there are none. So therefore, we're done checking the right side. And then because we finished with this 9, we are done checking all the items right of 8. And then because we are done with all of the left and right side of 8, we are now done checking all of the items to the right of 6. And again, we go down here to this array, and now we ask, is it sorted, right? And keep in mind that they are all locked in places in their respective indexes. So this is index 0, 1, 2, 3, 4, and 5. And now when we look at this array, let's just ask, is it sorted, right? So we have 5, 5, 6, 7, 8, 9. It is in fact sorted. And so that's pretty much how quicksort works when dealing with duplicates, is you want to just add in the logic. Is it less than, or is it greater than or equal to the number that you're comparing to? And that'll solve your issue as far as dealing with duplicates. Again, I know quicksort can be hard to wrap your head around, so if you have any questions or concerns, feel free to go ahead and leave me a comment, and I'll try my best to walk you through it.